Everybody, so one more time, please, let's welcome Tristan Hume.
Okay, so I'm going to be giving a talk on the Ruby standard library, and I planned on including a bunch of beginner stuff, as well as I made sure to include some advanced stuff so that everybody who's already an expert in Ruby, even they will find something that they didn't know before. So, do I have my slides? No, that's kind of, to some extent. So, just in case you want to look at this later, you can find it online, or you can read ahead and get spoilers. So, the Ruby standard library is actually a really great library. It has thousands and thousands of functions, and it contains both the built-in Ruby functions on core classes like array and string, as well as a bunch of miniature libraries that you have to include separately. And it's useful because you don't have to add dependencies to your project. You don't really have to rely on a library that might go out of style in a couple years. You can have confidence that the Ruby library is held to a certain standard of quality and that it'll be maintained, at least to some extent. And it's pretty well documented as well. And I personally find this useful because I write programming contests, and during a programming contest, the only library you're allowed to use is the Ruby standard library. So I've learned a bunch of things that I'll share with you. So one thing that you can do that's really good with the Ruby standard library is that there's great documentation that you can look up in a whole bunch of different ways. I personally use a program called Dash. That's a great OS X Apple program. There's OmniRef, which is a great online site, and RubyDoc is another pretty good one. And if you have Ruby installed on your computer, there's RI, which is a built-in command line tool. DevDocs is apparently good too. So I'm just going to give an example of Dash. So this is Dash, and with it, you can quickly search up any documentation in Ruby, and even other languages. So if I just type string and then tr, I get all the methods that have tr, or I can search up gsub, and I get all the different gsub methods. I can scroll through it, and it even has documentation for all sorts of other things. So I can look up documentation in Lua and stuff. And OmniRef is basically this, except online for Ruby. And Peter, you were saying something about...
Yeah, there's a website called devdocs.io, which is run by Hume, which is one of our Shopify guys.
Cool. Oh, right, I did see that. It was like DevDocs, I did see that. It was like Dash, except on the web. So let's start with some basic classes. Unlike some other languages, the basic classes in Ruby are really souped up with all sorts of methods. You can see just some counts here. Array 171 methods, string 166, and this is without any added libraries. And just using some of these fancy methods just to take a random sample of some of the methods in the array, we can see some of the interesting things Ruby has to offer. So I'm just going to start off with like a taste of what you can expect from this presentation. This is one of my favorite methods. It's underutilized, it's not that well known, but it's very useful. And what it is it takes advantage of the fact that the AND operator in Ruby calls toProc on its argument, and then passes that as a block to the thing you're passing it to, and then you can use that to as a short syntax. For example, here we're using it to capitalize all the elements in an array with just a symbol, compared to this, which is the longer version of doing it. Now that's a bit advanced, so let's get back to something more basic. Loops. Loops are one of the main differences from Ruby to other languages, because all Ruby, or most of Ruby's loops that you use every day, are actually part of its standard library. And this is a big selling point, because you get all this easy-to-read syntax and all these different loop types instead of having to rely on a few basic constructs. So where other languages you'd see fancy for loops, here you can just see 4 times 3 down to I, split hello world into each on that, and then there's just the basic loop, which just loops infinite times. This has the benefit of, unlike other languages, it makes the intent of the loop clear. There's both the, what the loop does and also what the intent of it was. For example, if I do a for loop from 0 to 3, in any other language, I could want to do something 3 times. I could be using it as the index in the first 3 elements of an array, or I could be doing something on the numbers 0, 1, 2, and 3. But in Ruby, by using the different constructs, I can make it clear. And I can also be sure that I don't have any off by 1 errors. If I write 3 times, I have confidence that it's actually going to run 3 times. And I can, if instead I'm actually talking about doing something on the numbers 0, 1, and 2, I can use range and then each instead. And although it does the same thing, it conveys a different intent. And this is one of the differences in Ruby. Lots of languages have functions, and even JavaScript has array.forEach. So you can do things like this, but only Ruby has it integrated into the language such that these loops really behave like language constructs. So here we can see that even with a custom function, where we have twice, which just runs the block twice, we can do break, and then if we scroll down, we can see that it only runs once. Break actually behaves like we expect, even in a custom loop. And this works for all standard loops. You can use break in any of them, and it'll do what you expect. And it also works with next, which skips to the next iteration. So let's look at just one of the most basic looping methods. It's a method on integers that runs a block a certain number of times. And you can see that it actually has this alternate form that takes an enumerator. And what that does is it allows you to combine the looping constructs with other methods in Ruby. So here what we see is we're combining times with a select on even numbers. So even if you don't know what select is yet, we'll get to that later, you can see that we've actually filtered our loop to only do certain numbers, even though we're still using the same looping construct. And kind of like these filters on enumerators, you can modify loops. So one thing that's often useful is if you're working with multiple arrays or just numbering a list, you often want the index of what you're doing. And you can use this withIndex function to do that on any loop. So here we have each with index, but you can do times with index, which would be kind of redundant, or down to with index, but all sorts of these things. You can just tack with index on it, and it'll pass in both the element and the index. Now let's move on to string manipulation. So Ruby has heritage from Perl, which was largely designed as a string manipulation language. So as such, Ruby has excellent string manipulation as well. And as we saw, there's tons of string methods. So one thing is we can even multiply numbers by strings. We can do things like convert between different bases, base 16, hexadecimal. And this works up to base 32, or 36, I think. We have handy methods like chomp, which removes a new line from the end of the string if it's there. So that's handy when working with user input. You don't want extra new lines hanging around. You just quickly call chomp on a method on the string. So let's look at one of the more powerful string methods. gsub is also known as global substitution. And what it does is it substitutes, it has a pattern and a replacement. And for every time it finds that pattern, it replaces it with its other argument. So we can see some examples down here. So we have a regular expression here, and we're substituting all the vowels in hello with stars. And we can also just pass in normal strings here. So you don't have to use a regular expression. You could just have a string as your pattern in case you wanted to just replace some simple thing. And you can even have a block that determines what gets used to substitute. And I mentioned that you could use regular expressions or you could use strings. And this actually comes from another powerful feature of the Ruby standard library. That's this method called case equality. It's triple equals. And what that does is it acts very much like checking if two objects are equal, except in certain classes, it's redefined to have extra functionality. So for example, on regular expression, triple equals is defined to check if a string matches that regular expression. And on class, it's defined to check if an object is an instance of that class. So you can use these in Ruby case statements, and it's built into lots of methods like gsub. Now back to some more simple string manipulation. I'm not sure if this is just a problem I have, or if it's a problem other people have as well, but how many people have been working with user input and then had their Ruby program crash because of a malformed UTF-8 character? Yes, at least one person, or yes, multiple people, good. So this isn't just me. Now this method was introduced in Ruby 2.1, I think, and it's a godsend. Basically what it does is it just removes all bad input from the string, so that you can be confident that this adding to your strings and center them or left or right align them. And sometimes a common use case when you're scripting is, it's not the most here.glob. And what this does is, some of you might be familiar with Unix shells have pattern matching, so you can run something on multiple commands. And Ruby has this glob function, which acts very much like that. You give it a pattern, like here matches ** matches any directory, things like that, and then it'll give you back an array of all files that match that pattern. So here we can see things that have different extensions. Just give you back an array of all those files so that you can manipulate them. So I have an example here that uses an alias of dir.glob. You can use dir.glob to, for example, iterate all files of a certain type in a directory. My webcam seems to be on, so perhaps the problem is on my end. Perhaps. Ah, excellent. Okay, must just have to share my screen again. Decent. So here you can kind of see again. We're just combining what we learned in the previous two slides to do some simple task that is kind of what you might do in a script. So we're taking all the markdown files in the current directory. We're reading them all in as strings, and then counting the number of new lines in them. So now I can see how many lines my presentation has at the time I inserted this into the presentation. Another handy class that comes built in is the time. And this is just kind of an example of the kind of handy methods that Ruby includes. They don't have very much, they don't give very much thought to whether something will be useful for everybody. There's not that much overhead, so they just include handy methods like .Tuesday, so we can see whether time is on Tuesday, and there's similar methods for .Saturday, .Friday. So just handy things like that. You can see that I actually fudged the dates, and I ran this code on a different day and then changed it so that it looked like Tuesday today. But yeah. And there's also an extra library. So although time is built in, if you require time, you get this extra method and some others called parse. And parse can just give you, given a string, it can give you back a time. And this is actually a really fancy method that exemplifies the kind of thought that goes into the Ruby standard library. Whereas other methods you might have to, or when parsing times in other languages, you might have to use a specific format. Time.parse actually uses fancy logic to determine and read all sorts of different formats. So you can paste in a big fancy HTTP date, or just a simple one, in all sorts of different things, and it'll work for all of them. So let's move on to the final basic class. And this is kind of the mother of all basic parts of the standard library, and it's very useful. It's a module that's included in all sorts of different things. For example, arrays, strings, and files. And that means that you can use any of these methods on any of these things. So here's just an example of what happens if you overuse a numerable in a single line. Here we have one line that finds the most common starting letter in the English dictionary. We're just opening our dictionary, downpacing all the words, chunking it by the first letter, finding making little groups of it, and then sorting it. So let's start with something basic. And map is everything that is basic about a numerable. Basically what it does is it takes every input from a collection, and that's what enumerable does. It operates on collections of things. So arrays are an example, ranges are an example, strings are an example. So here we're doing, on the collection of numbers 1 to 4, we're doing a transformation based on a block of I times I. So that's just squaring all the numbers from 1 to 4. And we get back an array of that transformation applied to every element. And here we're just, you see that there's also an alias called collect. So for 4 times, we're just giving back cat every time, so we get an array of 4 cats. The kind of cousin of map is reduce. You might have heard of the MapReduce algorithm that Google is famous for using. And reduce just takes a bunch of things in a collection and then kind of applies a transformation to all those elements in one thing. So unlike some other methods, this also includes a convenience form that, given a symbol, it can use that. So here we're summing a bunch of numbers, and we can also multiply a bunch of numbers together, or find the longest. So it's just handy for taking a bunch of things and merging it down to one thing. There's also a bunch of filtering methods. So we can filter on certain qualities. So we can take the numbers from 1 to 10 and filter whether they're divisible by 3 or whether they're even, and get back an array of those. And there's kind of an inverse that's reject that does the opposite and gets rid of things where the block returns true. There's also predicates like all. It does exactly what it says. If all the elements in something match this, or this block returns true for, it will return true. Otherwise false. And there's also any, which does also what it says. This is just something that people switching to Ruby from other languages might get caught up on. Lots of other languages have a function called that does like max of A and B, 2 parameters. It returns the maximum one. In Ruby, they don't have that because it's actually a generic method on a numerable. So if you're trying to just find the max of 2 elements, you use just an array literal and .max. But it's actually a lot more general than that. We can use some of our enumerable methods and our fancy enumerator times to just create an array of 10 random numbers. And then we can find the maximum, and we can even find both the minimum and maximum at the same time. And you'll notice that there's also a suffix that you can use called by. And this has a lot of methods have this. There's min by, there's sort. There. Nope. My laptop around. Your network connection is experiencing difficulties. Ah, there. Okay, it's fixed. Good enough. close enough to fix. You can get a preview of the next slide. Okay, so grep just searches for a pattern in an enumerable. So you can use the same triple equals here. And that's why you can search for a regular expression, you can search for if a number is in a range, or you can just give it a string. And it's just kind of a more beefed up version of select. There's also a kind of new feature in Ruby 2.0 that's lazy enumerables. And what these do is they only do computation when they need to. And what that means is, say you're trying to find the first 10 words in the dictionary capitalized. If you use Ruby, you could say words.mapCapitalize.take10, and that would take the first 10 elements. But behind the scenes, what it would be doing is capitalizing every element of the dictionary, which is a lot of words, and then only taking 10 of them. But if you use lazy, what it'll do is when you say take 10, it'll say, oh, I have to capitalize the first 10 elements, and then it'll only capitalize the first 10 instead of all of the elements. So sometimes it's more efficient, but sometimes it adds overhead. And you can also do cool things like work with infinite sequences. So for example, here we have an infinite list of all the Pythagorean triples, and you can just take them lazily. Some of the methods that are on collections aren't actually an enumerable just because they don't fit there or they fit on specific things, and I'm just going to talk about some of those. Flatten is a handy method when working with lots of nested arrays. It just takes an array that's a whole bunch of levels and merges it into one thing. This could be multi-dimensional arrays. You just want to find all the elements in a grid, or just simpler ones like JSON data structures. Transpose is another handy one when working with grids. If you have a two-dimensional array, it'll do the equivalent of, if that two-dimensional array represents a grid, it'll do the equivalent of flipping that grid so that you can, it works from the other way. So rows becomes columns and columns becomes rows. And this may not seem that useful, but it's very handy, I found, in AI work. So for example, when writing AIs for web contests, I often find it handy to write some function. A lot of games that you write AIs for are grid-based, like chess and checkers. So you can write one function that works in one bracket. Instead of writing a separate function for columns or making your function more general, you can just rotate the entire board and then run your function again. Now let's move on to some of the more complex things. And if you advanced users have been bored by the enumerable methods, this is where you'll learn stuff. These are more specific mini libraries that are not really useful in all programs, but they're for very specific things. And there are a ton of them, and you have to require them. So here's a big list of all of them. I bolded some of the cooler ones, but you can just see how many of them. So for example, there's abbrev, which finds prefixes that are unique to a list of things. So this is kind of like what autocomplete does. So if you type in P in Google, it'll find what starts with P. And there's an algorithm for that built into Ruby. And there's all sorts of these things, like a set, which is just a built-in set data structure built on top of hash, and all sorts of things. So I'm going to talk about some of them. So just an example of the cool stuff you can find is PP, which is a pretty printer. And what that does is it works like the P method, which is a debug print method, except it also formats the thing you're printing in a nice way. So if you print an array normally, or a grid normally, you'll get this big, long thing. But if you use PP, it'll actually format it in a nice grid. And the other thing it can do is if you're working with big objects, it can, instead of making it one big, massive block of text, it'll actually format it nicely with all the different parts. Another big category of a lot of these libraries is support for internet things. And a lot of these names are self-evident, what kind of internet protocol they do. So I've just included some examples of what kind of things you could do with these libraries. So you could do FTP to log into FTP servers and deploy websites to crappy hosting providers. To read emails, you can use Telnet to view Star Wars in ASCII. You can scrape RSS speeds for your website. And it even has a concurrent DNS resolver. So if you're ever curious about like how many 5-letter domain names are left that also have 2 characters of your name in them, you can just write a script to scan all 5-character domain names pretty quickly. There's also a couple libraries that are handy for testing and debugging. There's Minitest, which is pretty well known. It's Ruby's built-in library for unit testing. There's a built-in benchmarking library. There's Coverage, which just checks how many lines or how many times each line of code runs in a Ruby program. So you can see whether your test suite covers all cases in your program. And there's a built-in profiler. And one thing that is actually pretty useful is most of the time I use print statements and puts and p in debugging, but sometimes it's handy to have an actual debugger where you can step through your Ruby code. And for that case, I don't want to go into an IDE or like learn a special Ruby debugging library. I just want to quickly step through my code. And with this, it's the built-in Ruby debugger. It's not quick. It's not very, it doesn't have a ton of features, but it's very handy. All you have to do is require debug at a certain point in your program, and you'll get a GDB-like prompt. So you'll get a prompt like this. One moment, wait for the screen to update. So you can print things, expressions in your program. It has all sorts of different commands. You can type H to do all that. There's breaks, there's watch, there's catching exceptions, going up, down, stepping through in all sorts of different ways. So it's a pretty, has all the functions you need in a quick little debugger for just debugging a short problem. Then you just delete the required debugger line when you're done, and no trace of it exists in any of your files. Another big category is parsing of various languages and data formats. Big one is YAML. It's very useful for just storing things in Ruby if you're writing a quick script and you want to read it. Excellent. Okay, good. So here we just have some of the other libraries and formats that Ruby supports out of the box. JSON has an interface very much like the YAML library, and there's also an XML library that's very fully featured. It's not the fastest, but it has all the things. It has multiple parsers, like an event-based parser, a tree-based parser. I think there's apparently 7 of them from my count, and it supports XPath document formats, and it's really quite feature complete. There's also a CSV library. If any of you are scientists or statisticians, you'll know CSV. Base64 is just a way to store binary data in only ASCII characters. Ripper is a library that can parse Ruby scripts using the same parser that the Ruby interpreter itself uses. So you can write scripts that if you're curious about how much you swear in your Ruby programs, you can write that, or whether your variable names are often animals, you can check that. And there's option parser, which is used for command line programs. It'll parse all those weird flag notations for you. There's even a generic parser generator that you can give it a grammar specified in a certain format, and then it'll generate a parser for you for that language. Another thing I discovered while writing this presentation, and I was looking up how to include Ruby documentation in Ruby, accessing it, I found that RDoc, that's a library in Ruby, actually has a markdown processor that even supports GitHub flavored markdown. So although there are like hundreds of markdown gens, there is actually a markdown processor built into Ruby. It's actually pretty decent. It doesn't have the best library formatting, and it's not that well supported compared to some of the more common markdown extensions, but it has a decent amount of features. And it's quick if you don't want to install a gem for some reason. Path name is just a handy thing for manipulating file paths. It can do things like find an absolute path. Just scroll down to some examples. It can do both manipulations on the path names themselves and on the files that they represent. So you can check if things are directories, check if files exist, find the absolute path to some file, and this all works in OS agnostic way. So you can do the same commands on Windows, and even though they use a different path format, it'll still work. This is just a handy thing for you JavaScript fans. Basically what it does is it's a wrapper over Ruby hashes that allows you to access the things in a different way. What it does is it just uses the metaprogramming functions to allow you to access attributes, even though you don't specify them. So you can just set random attributes and access them like a hash. And this is very much like how JavaScript does it. Not everybody knows that Ruby actually has a built-in crappy GUI library. It's very rarely used. Almost no one uses it. Information on using it is hard to find, but there are some tutorials out there. And it's not very good for anything big, but it has the advantage of it's one of the few Ruby libraries for GUIs that's actually easy to install because it's already there. There are other libraries for doing GUIs in Ruby, but they're either hard to install because you actually have to install a separate C library and then get that linked up with Ruby, or some other thing. But TK actually includes in all Ruby distributions, even Windows, out of the box. And it's actually pretty simple to use. It has all sorts of things, layouts, buttons, lists, stuff like that. Another one of these lesser used libraries is Win32OLE. As you might expect, it only works on Windows. And what it does is it interfaces with the same application layer that Visual Basic for Applications does. So you can access all the things that people use when scripting Excel macros to control Microsoft Office applications or even other third-party Windows applications. So now all of you have absolutely no excuse to ever use Visual Basic again. If I catch you using Visual Basic, I'll report you to the Ruby police. So these last two libraries, they might seem a bit like sketchy and who would use this and rely on this, but sometimes they're actually useful. A couple years ago, I was working for a company, and they had this kind of hack days-like thing where you had one afternoon to work on any project that was related to the company. So previously, I had heard about this division that was doing document processing. They were taking in text files and then doing some things, looking for the right stuff in them, and then pasting them into an Excel sheet. So in that afternoon, I decided to automate that process. So I used a TK GUI and a Win32OLE to automate the, it would read the text files, you'd use the GUI to select which fields were where in the text file, and then it would remember that, use that for multiple text files, and slurp all the things into an Excel worksheet. And although it was not user-friendly, It was not robust, but I wrote it in one afternoon, so I didn't have to learn any other libraries or figure out how to install anything on the computers at work. I got this done, and it turned out that this function had previously been performed by 10 data entry workers. Sorry, guys. So let's get into some of the more obscure parts of Ruby that I'm pretty sure no one uses. If you've ever used Lisp, you might know that Lisp has fancy things like if you divide two numbers, it'll actually give you a fraction type back. And Ruby can do this too. If you require the math_n library, it'll improve the math precision so that dividing returns rational numbers, and it won't round intermediate results, even when working with integers. So you get more precise performance or results. And this is my favorite class. It just shows that the developers of Ruby really like people like me. What this class does is it's a prime number generator. And it has multiple generators built in, the sieve of Eratosthenes, trial division, and pseudo-prime generators. And basically, prime numbers aren't exactly that useful very often in industry. I would never see myself using this as part of my job. And prime numbers are useful in science and math, but in those cases you want a really fast prime number generator that can generate really large primes, which this is not. So the only use case this is good for is for arbitrary computer science challenges, like if any of you have heard of Project Euler. And I've used this in programming contests, where it's very useful because you don't have to write your own prime generator. You just do prime.each 100 while your competitors in the contest are figuring out or trying to remember how you generate primes. So the only other practical use I've found for this is if you ever find yourself giving a presentation about obscure things in the Ruby standard library. And so I thought that this was very useful to me as a finishing thing, just to show some of the obscure and random things that are in the Ruby standard library. And that's all. Thank you. Any questions about things? Did anybody not learn about something that they didn't know before? I can get Dash out. Okay, so let me go to my someone didn't learn something. I'm somewhat skeptical that they didn't know about, or that they already knew about every single one of these modules, but I can go to my module list and see if I can find some of the more obscure ones. Let's see. Let's just take a tour of some of the really obscure parts of the Ruby standard library. Wait, wrong keyboard shortcut. There's the etc library, which looks in your etc files in Unix systems and it gets common information. So for example, it can get your current login name and get your password name or PW name, whatever that is. There's a thing built in. There's actually 2 web servers built in. There's the more common one that's WeBrick, but there's also another library built in for doing web servers that's gserver. There's all these net libraries. There's a profiler, there's the pretty printer, there's RDoc, there's readline. I'm somewhat skeptical that anybody knew about resolve. I certainly didn't. Found it in the list of packages. It does concurrent DNS resolution. There's built-in OpenSSL support. There's some sub things of YAML. There's Thwaite, which is an interesting library that it's for concurrency, waiting for termination of multiple threads. This is just some examples of the really random things that you can find. One that's actually kind of useful is English. It just seems kind of funny to require English. And notice that it's one of the few Ruby libraries where you actually capitalize the thing you're importing. You almost never do that in Ruby, but you do in English because you capitalize things when you're starting a sentence. And what it does is it renames some of the more obscure constants. Like there's like $, and all these things that were inherited from Perl. It gives them English names. Let's look at some other random things. Let's see, random mouse movements. Let's look at PTY. I think I know what this is. Pseudo terminals. So you can like run Vim in Ruby and interact with it through this pseudo terminal. You can do OpenURI is pretty useful. It allows you to use things like I/O methods and open to read web pages. It's a quick way to just like get pages off the internet. There's things like extmk. Okay, my documentation search can't even find it. That obscure. Let's see. Oh, there's Rinda. There's this obscure feature of Ruby that not many people use called DRB that is for distributing Ruby programs over multiple computers. So you can have like a network of computers that are all running Ruby programs and that they communicate with each other. And Rinda is just a distributed computing library for DRB that's included. You can use scanf like you would use in C, with the scanf library. You can use string I/O, so you can use strings as I/O things and write and read to them and seek through them. ERB, if you've ever used Rails, those are the built-in templates, although I think they use a better library than this because it's the library they use is faster. I think it's a Rubus, but it might have changed. There's also a date library, which is interesting since time also has a date involved, but there's date and there's date time as well. So that's kind of a confusing duplication-ish thing. File utils is kind of handy when writing scripts. Basically, it gives you all the common Unix commands like cd, pwd, mkdir, ln-s, all those things as Ruby commands. And I'm pretty sure these work on Windows as well, but I can't be certain. Yeah, I'm pretty sure that most of these are actually implemented in Ruby, so that even though they're Unix commands, they actually also work on Windows. So you can use this to do cross-platform things like file copies. Anyway, I hope that was an interesting look at some of the cool things that are in the standard library, and I hope not everybody recognized every one of those. And if they did, they've probably been reading the list of every single thing in the Ruby standard library like I did. It's included on the first or third page of this, fourth page of this slideshow right here. There's a link to it. You can just scroll through all the different things and see what kind of things are there. Anyway, that's it. Any other questions? Yes? Sure. Xander?
I had a question about the sort by, or sort by. Is sort by actually add any functionality behind sort of notation?
It's just a simpler notation. You can pass sort a block and then use the like open angle bracket equals close angle bracket to compare two things. But since you're probably almost always going to be using open angle bracket equals sign close angle bracket in that sort block, you can just use sort by and it's simpler.
And I have one other question. The Markdown library, do you have any idea what you're looking when that was added?
I'm not actually sure. It seems fairly recent. I'm pretty sure it said something. It definitely supports GitHub flavored Markdown. I saw that. CSS apparently. Let's see if I can find a date.
Yeah, I think the
No, I don't have them downloaded now. But it would be interesting to see. Anything else? Yes?
I have a question about some enumerators. You have this really long function that basically chain a lot of
Yep.
different kind of enumerators and enumerators. Sometimes when I'm writing code, I always struggle with, well, I want to make this look prettier or long. So can you tell us about the chaining that many enumerators one by one? And if it's just better to use each and then manually do all that?
This is more memory heavy because unless you're using lazy enumerators, it will actually take all the words in the dictionary, create a separate array in memory that has all these dictionaries lowercase, and then create a separate data structure that has all them chunks and things like that. So it's more memory intensive, not that much more CPU intensive other than the struggles associated with dealing with that much memory. And lazy can reduce those memory concerns, but it only works with some of these numerable methods. It has a list of the ones it works with, and if you don't use those ones, it'll just default back on the old behavior. So it works with map, collect, flat mech, select, reject, grep, zip, take while, drop, and drop while. So that can be used to alleviate some of those concerns. But another concern is readability. Some people like these, some people don't. They're certainly quick to write if you're writing a quick script and no one else is going to look at it and you're never going to maintain it. And they're cool for showing off impressive Ruby skills, but other than that, they might not be the best idea. Yes? The parse? Yes. The time parse, you can, there's also a specific thing that's for specific date formats. Time parse, I think, supports all of them, so you don't have to use the specific method, but so you can parse specific formats like RFC 2822, which is, I think, is used in HTTP addresses. You can specify time zones with abbreviations in certain formats. So it has some notes here about ambiguity, like CST using an American Chicago and American Havana. But yes, it supports UTC time formats. Michael?
So, using anything like programming competition and stuff, oftentimes your code isn't timed.
Your code isn't timed, but part of the main thing in programming contests is that it's all about time constraint. You only have 3 hours, and you have about 5 questions, which are all reasonably difficult, that take a lot of time to complete. So a lot of getting good at programming contests is getting good at writing code quickly. And you're never going to use the code again, so you also program in a completely different way than you would normally, where in a way that uses really long chains like that, and names variables not that well, things like that.
And so, that's some of the performance requirements too, like that's
There are some performance requirements, yes. There's not that many. They're pretty well optimized in most cases. Most of the time when I'm doing programming contests, I don't have time to get out my profiler. I just completely rewrite my algorithm. But there are some things like, I think it might have been permutation. Permutation is pretty decent, but sometimes it can be slow. It's not something that you use really outside programming contests, though. Just like given an array of 1, 2, 3, it'll give you all the different orderings of 1, 2, and 3. But most of the methods are implemented in C. One thing to watch out for in terms of that performance is that, actually I do remember some performance things. The basic classes are pretty much all implemented in C, so they're all really fast. But the external libraries that you have to require, a lot of them are implemented in Ruby, which means they can be very slow. So one example is the math-n library I was talking to you about. It mentioned briefly something about rational. Rational is a class that you can do fractions with in Ruby. And the thing about rational is that it's implemented in Ruby, so unlike normal Ruby math, it's ridiculously slow. Another thing is set. Set is a really handy notation for doing sets of elements. It's just like unique sets of things, but really it just uses, it's a layer over hash, so it's faster just to use a hash directly. And those are the two things I remember that are slow. Anything else? Nope? Okay, thank you.